In this video, I'll explain the concepts of VXLAN and VTEPs and how our NSX logical switches use these objects to allow layer 2 traffic to traverse a layer 3 network. So first off, what is a VTEP? Well, VTEP is a VM kernel port that's specifically required for VXLAN. Now with vSphere, we have two types of virtual switches. Right? We have our vSphere standard switch. And the vSphere standard switch is a switch that's configured on individual ESXi hosts and has a fairly limited feature set. Then we have the vSphere distributed switch, which has much more features and has a centralized management plane in vCenter. So when we create a vSphere distributed switch, we have a central point of configuration, and we can easily make changes to many hosts at once. Now with NSX, we have a third type of virtual switch called a logical switch. And the logical switch is configured using something called a VXLAN network identifier, or VNI. So prior to creating a logical switch, we need to establish a pool of these VNIs. Valid VNIs begin at 5,000 so that they can't be easily confused with VLANs. And each VNI serves as a unique logical identifier very similar to a VLAN for a logical switch. So as you create logical switches, VNIs from our pool are automatically assigned. And that's kind of a little bit of the background of what happens with these logical switches. Now, when you establish a logical switch, there's going to be a VM kernel port called a VTEP that gets automatically created. Right? And we'll talk about how that happens a little bit later in this video. You might have one VTEP for a logical switch. You might have 3 or 4 VTEPs, right? They're automatically generated. And I'll show you how those are created in just a little while. But for now, just understand that the VTEP is a VM kernel port. And the job of the VTEP is to perform VXLAN encapsulation and decapsulation. It adds headers to traffic that's about to traverse the physical network, like a VXLAN header, an IP header, and a MAC header. So the goal of these VXLANs is simply to ship traffic from one ESXi host to another across some physical network. In this diagram, we have two virtual machines that are connected to the same logical switch, VM1 and VM2. And you'll notice that VM1 and VM2 are on the same IP address range, the 192.168.1.10 and 192.168.1.11. So this is two virtual machines that are connected to the same logical switch. And if they want to communicate with each other, that's going to be layer 2 traffic. Right? If VM1 wants to ping VM2, for example, the source IP is going to be the IP of VM1, the destination IP, the IP of VM2. Right? There's no need to utilize a default gateway or anything like that. This is just straight up layer 2 traffic. And we can also see the source MAC is the MAC address of VM1. The destination MAC is the MAC address of VM2. However, these two virtual machines are on different ESXi hosts. And when we have a logical switch and VMs that are on different hosts, that traffic is going to have to traverse a physical network that we call the Underlay Network. And in order for that to happen, that traffic is going to have to flow through a VTEP. It's going to have to get VXLAN encapsulated. And essentially what's going to happen is the VTEP of the first host is going to ship that traffic over to the VTEP of the second host. So let's take a look at how this works. Right now, my source and destination IP and source and destination MAC are the addresses of my virtual machines. When this frame arrives at the VTEP is going to add a new set of headers. It's going to add a new source and destination IP and a new source and destination MAC. The source IP is the sending VTEP. The destination IP is the receiving VTEP. Right? And that traffic will traverse the physical network, arrive at the destination VTEP on the other ESXi host. And now it's the job of the destination VTEP to strip away these VXLAN headers, to remove this additional source and destination IP and source and destination MAC that specify the IPs of the VTEPs. And as it strips away those headers, it will eventually arrive at the VNI field of the VXLAN header. And if we go back in our presentation just a little bit, let's take one more look at these headers. In red, we see the original frame with the original payload, the data, the source and destination IP of the VM, the source and destination MACs of the virtual machine. The VTEP is adding those headers that you see in blue. A VXLAN network identifier, a source and destination IP of the VTEPs, and the source and destination MAC of the VTEPs. So when that traffic arrives at the destination VTEP, all those headers that we just saw in red need to get stripped away so we can get back to the original frame with the source and destination IPs and MACs of the virtual machines. And as the VTEP is decapsulating that frame, as it's removing those VXLAN headers, one of the headers is going to be the VNI 5001. And that's how the VTEP knows which logical switch to drop that frame onto. So when it drops that frame onto VNI 5001, it's going to drop it there with the original headers intact, and now the frame can arrive at my virtual machine. Now I know this is a little confusing at first. Let's take a look at another example. In this case, our physical network is going to be a little bit different. Now we're going to insert a router into the middle of this mix. So let's take a look at virtual machine 1 now wants to communicate with virtual machine 2. And notice their addresses haven't changed. Right? They're both still connected to the same logical switch. And when they communicate, as far as my virtual machines are concerned, it's a layer 2 communication between two VMs that are on the same switch. So here's what my headers are going to look like. VM1 will generate a ping or some other traffic to VM2. And the source IP and destination IP are the virtual machines, and so are the source and destination MAC. Now that frame is going to flow through the logical switch and hit the VTEP. Quickly, before we examine how those headers are going to change at the VTEP level, just notice in this case, my VTEPs are on different IP address ranges. The VTEP on host 1 is 10.1.1.10. The VTEP on host 2 is 172.16.10.10. And I've got a physical router in between these ESXi hosts. So this is where VXLAN provides us some major benefits, because now I can have a layer 2 network that extends across a physical layer 3 network. So here we see the frame arrives at the VTEP, and the VTEP is going to encapsulate it, right? The original frame is going to be left intact, but the VTEP is going to put new headers on the outside of it. This is called our outer headers. And the source IP is going to be the VTEP of host 1. The destination IP is the VTEP of host 2. The source MAC is the MAC address of VTEP 1. The destination MAC is the MAC address of my router. So as this frame arrives at the router, let's kind of walk through what the router is actually going to do. Right? The router will start to analyze these headers. Right? What it'll say is, it'll notice that the destination MAC is RMAC1. Right? That's the MAC address of an interface on the router. And it'll look at the source MAC, and that'll be the MAC of the VTEP. And so the router will think, hey, here's a layer 2 frame that is destined for me, that belongs in this router. So it'll strip away that source MAC and that destination MAC, and that's where those layer 2 headers stop. And the next thing it'll do is it'll analyze the destination IP. And in this case, my destination IP is 172.16.10.10, which is my VTEP over here. So the router will realize, hey, that's not my destination IP. This packet is destined for something on the 172.16.10.0 network. And the router will then do what a router does, right? The router will say, hey, I've got an interface on that network over here, right? And so what it'll do is it'll then send that packet out that interface, right? And that's the job of a router, is to take any packet that's on one network and route it to another network that it's destined for. So our router does its job, or receives that frame, and it looks at the layer 2 headers, looks at the layer 3 headers, routes it out to the appropriate network. And here's what our headers look like after the fact. Now, a few things have changed in this case. The source IP is still the IP address of our sending VTEP. The destination IP also has not changed. It's the IP address of the receiving VTEP. And then we have our source MAC, which is this interface on the router, and the destination MAC, which is now the MAC address of the VTEP. And so now what will happen is the VTEP will receive this frame, and the VTEP will go through a similar process that the router did. The VTEP will analyze the source and destination MAC, and it'll say, okay, this is destined for PMAC2. That's me. Let me go ahead and strip away these layer 2 headers, and then it'll analyze the destination IP. And the VTEP will say, that's my IP address. Let me go ahead and strip away the IP headers. And the next header that it's going to see, the next header the VTEP will see, is a VNI header identifying which logical switch this frame is destined for. And that's how the VTEP knows to forward that frame to logical switch VNI 5001. So the VTEP has now stripped away all of those outer headers. My frame is delivered to the logical switch. And now the original headers are used. We have our original source and destination IP, our original source and destination MAC. So now the frame will arrive at virtual machine 2. VM2 will say, this is my destination MAC. Let me strip that away. And it'll look at the layer 3 header. It'll see that this is this virtual machine's destination IP. And at that point, it can examine the payload. Now, hopefully this has really clarified the role of the VXLAN and VTEPs. But if there's still confusion, I recommend going back and rewatching this video again from the beginning, and hopefully that'll help clarify any questions you might have. Now we're going to proceed on here. We're going to talk a little bit about the impact of quality of service in this environment. Right, so here we see again, my same virtual machines on the same networks, and we have our VTEPs, which are on different networks, and a physical router in the Underlay Network. And virtual machine 1 is going to generate some traffic bound for virtual machine 2, and this traffic has been tagged with a COS header and a DSCP header. We've appended quality of service values on this traffic to ensure that as it traverses the physical network, that it'll be prioritized appropriately. What happens is when the VXLAN encapsulation takes place, the VTEP is actually going to recognize those quality of service values and also append them to that outer header. Because remember, all of the addressing and all of the quality of service information that this VM is applying to that frame, that's all going to be obscured behind an outer header that the VTEP creates. So the VTEP will pull those COS and DSCP tags, place them on the outer header, and that way our quality of service configurations can be maintained as this packet traverses the physical network. Now in our next video, we're going to take a look at how these VTEPs get created and how many VTEPs are actually going to exist on each logical switch.